Okay, this is Mrs. Myers, and we are going to review for our 1.7 and 1.8 test. That's Unit 1, Lessons 7 and 8. Okay, so the first of all, the four terms that are most important here are the four terms we learned about parallel lines cut by a transversal. So we'll call our transversal T, let's call this line M and line P. Okay? Actually, I'm going to call that line Q so it doesn't sound like I'm saying P and T sort of sound alike. So Q, M, and T. All right? If M is parallel to Q, then we have all these relationships that we learned about. And the four relationships are alternate interior angles, alternate exterior angles, corresponding angles, and then same side interior angles. Well, if we number these, right, alternate interior angles, can anybody give me a pair of alternate interior? Say again? 4 and 5. Good. So alternate interior, an example would be angle 4 and angle 5. Remember, interior means all of the space that's between the two lines. So our yellow part, that's the interior, right? And then the exterior is everything else. So with a few people today, I talked about it as, think of it like this is like a sandwich. The two parallel lines make a sandwich. That's the bread. Sandwich is everything inside. Transversal is like a toothpick that goes through, right? So the interior is inside your sandwich. Your transversal is going straight through. Anything that's outside of that yellow space is going to be exterior. Okay, so what about a pair of alternate exterior angles? Can you give me a pair of those? Alternate exterior? Yeah. 2 and 7, good. Okay, another pair would be 1 and 8 for alternate exterior. Another pair of alternate interior would be 3 and 6, right? But I'm just doing one example of each. Corresponding, can somebody give me an example of corresponding? Yep. 1 and 5. Now there's lots of corresponding. 1 and 5. You could have 2 and 6, or 4 and 8, or 3 and 7. With corresponding, remember, one's interior and one's exterior. And they're on the same side of the transversal. Okay, all of those, alternate interior, alternate exterior, and corresponding, if the lines are parallel, okay, well, let's mark these parallel then. If the lines are parallel, all of these are congruent, right? So alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent, only if the lines are parallel. What about same side interior angles? Can somebody give me a pair of same side interior? Yeah, maybe. Yep, 4 and 6. And same side interior angles, if the lines are parallel, same side interior are supplementary. Okay, these are the theorems from 1.7. Stating that if the lines are parallel, that's the key. If the lines are parallel, then alternate interior angles are congruent. That's the alternate interior angles theorem, if the lines are parallel. If the lines are parallel, then same side interior angles are supplementary. That's the same side interior angles theorem or postulate. It doesn't matter which one you call it for this chapter. Okay? Those are the theorems. In that section, every single time they told you the lines were parallel, and then they had you relate the angles in the way that they were supposed to be related. Once we moved on to lesson 1.8, okay, the difference now is they are going to give you a relationship about the angles, and then you're concluding the lines are parallel. So instead of saying if lines are parallel, it's going to be if alternate interior angles are congruent, if alternate exterior angles are congruent, if corresponding angles are congruent, if same side interior angles are supplementary, then lines are parallel. So that's the difference. I think probably most people are wanting to practice proofs. I'm guessing that's probably why most of you are here, right? So let's put this into a proof. So this is actually the last page on the Geometry 22 packet. If you are a Geometry 21 student, some of these might be the same, but otherwise maybe just write it on a piece of paper. Okay. So I'm going to look at number 15. Angle 1 and angle 3 are supplementary. Angle 1 and angle 3 are supplementary is our given. We are trying to prove that M is parallel to N. Okay, if we are trying to prove that, right, then we want to get two angles that relate in one of these four ways, right? We want to get two angles that are either alternate interior, alternate exterior, etc. So 1 and 3 are supplementary is a given. 1 and 3 don't have a special relationship. They're not one of those four types of angles. Which angles in this diagram would have one of those relationships? 2 and 3. What kind of angles are 2 and 3? Corresponding. So, right now, can I say 2 is congruent to 3? No. Why not? Why can I not say 2 is congruent to 3 right now? Yeah, Dylan. Because we don't know the lines are parallel. They have not given us that information. If we wanted to say 2 is congruent to 3, we would have to first know that the lines are parallel. So this is actually going to be a converse. This is actually kind of working in reverse. We want to get 2 congruent to 3 so that then we can say the lines are parallel. Okay? So 21s, bear with me, I'm going to do a flowchart proof, but then I'll do a 2-column also. Okay? So angle 1 and angle 3 are supplementary. This is what we're starting with. That's a given. We're trying to get 2 congruent to 3. I'm kind of stuck, right, with our given. There's not too far I can go with that. I could say measure of angle 1 plus measure of angle 3 equals 180. That's about the only thing I might be able to say from that given. But it's not helping me get the lines parallel. So I'm kind of stuck. When that happens, you have to look for something else. And the place to look would be into your diagram. So look to your diagram and say, is there any other relationship that I see just in the picture? So you've kind of like taken the given as far as you can go. Look at the diagram. Is there any angle relationship that I can state from this diagram? Yeah. 1 and 2. How are 1 and 2 related? They're a linear pair, which makes them what to each other? Supplementary. So we could say angle 1 and angle 2 are supplementary by the linear pair postulate. Well, if 1 and 3 are supplementary, and 1 and 2 are supplementary, what could we do from here? Now we've got at least 2 pieces of information that maybe we can relate together. Yeah. Okay, so there's 2 ways of looking at this. You could say the measure of angle 1 plus the measure of angle 3 equals 180, and the measure of angle 1 plus the measure of angle 2 equals 180, and then set them equal to each other. That's what you mean, right? Okay, is there a shortcut? Okay, not 2 equals 3, but 2 is congruent to 3 because congruent supplement. So if we have 2 angles, 2 and 3, are both supplementary to the same angle, angle 1, right? Therefore, 2 and 3 are going to be congruent to each other by the congruent supplements theorem. Well, now if 2 is congruent to 3, now can I say M is parallel to N? Am I ready to say that yet? Yep. If 2 is congruent to 3, now I can say M is parallel to N. $1,000,000 question, why? Yeah. Good. You win $1,000,000. 2 and 3 are corresponding angles. If corresponding angles are congruent, so here we said that our corresponding angles were congruent. If corresponding angles are congruent, then the lines are parallel. If we're concluding lines are parallel, it's going to be converse of the corresponding angles theorem. So how do you know which converse to use? You use whichever one is the type of angles that you've said are congruent. Okay, now, you wanted to do it setting them equal to each other, and that's not really wrong, it's just a little bit longer. So, before all of this, that would be definition of supplementary, right? And then same thing here. Then you would set them equal to each other. Substitution. And then subtract 1 from both sides. Subtraction. And then they're congruent by definition of congruent. A little bit longer, right? So the congruent supplements theorem really eliminates all of that. Okay, if you're watching this video, you could always pause or rewind or whatever if I erased that too fast. Just quickly, if you want a 2-column proof, it's the same thing. It's just going to be separate steps. Angle 1 and angle 2 are supplementary by a linear pair postulate. Angle 2 congruent to angle 3 by congruent supplements. And then M parallel to N by converse of corresponding angles theorem. Okay,